Hello children, welcome to Trigonometric Identities part 2. Okay, so let us solve some more examples. One plus 10a into 10b whole square plus 10a minus 10b whole square is equal to sec square a into sec square b. This we are going to prove. Okay, obviously the left hand side is more complicated. So let us start from LHS. We can convert to sine and cos, but it will become more complicated. If you can see here in the left hand side or in the right hand side we do not have denominator, but if we convert to sine and cos we will get denominator. So let us avoid sine and cos this time. If we expand both this, okay, if we expand we will get here 1 plus 10 square n square a plus b whole square, 1 plus 10 square n square b plus 2 10a into 10b. If we expand this, we will get 10 square a plus 10 square b minus 2 10a into 10b. That means 2 10a 10b can be cancelled. So let us expand. Okay. 1 plus 10 square a 10 square b plus 2 10a into 10b plus this part is over. Now expand this part. 10 square a plus 10 square b minus 2 10a into 10b. Okay, 2 10a 10b, 2 10a 10b cancel. Okay, so 1 plus 10 square a 10 square b plus 10 square a plus 10 square. Okay, let us take 1 plus 10 square together. Okay, then these two together. Okay, so next step 1 plus 10 square plus from these two 10 square b can be taken common. So remaining is 10 square a plus 1. Okay, so now we have how many terms? When we expanded, we got 1, 2, 3, 4, 5, 6 terms. 2 terms got cancelled. So remaining were 4 terms, 1, 2, 3 and 4. These 4 terms I have converted to 2 terms. Okay, factorize, always try to factorize. Okay, 1 plus 10 square a, 1 plus 10 square a, it can be taken common. So 1 plus 10 square a common, remaining is 1 plus 10 square b, completely factorized. Now what is 10? 1 plus 10 square a? Sec square a, because sec square a minus 10 square a is equal to 1. So simply sec square a is equal to 1 plus 10 square a, or in place of 1 plus 10 square a you can put sec square a. Similarly, in place of 1 plus 10 square b we can put sec square b, which is RHS. Which is RHS. Hence proved. Okay? Hence proved. Let us move to next example. 1 plus cos a plus 1 by cos a plus sin a minus 1. 1 by cos a plus sin a minus 1 plus 1 by cos a plus sin a plus 1 is equal to cos a plus sec. Left hand side is more complicated, so let us start from left hand side, and it is equal to, anyhow if we can remove the denominator, automatically we will get the RHS. Okay, see, individually they cannot be simplified. Okay, so let us take LCM. LCM is cos a plus sin a minus 1 whole into cos a plus sin a plus 1. Okay, so the numerator will be cos a plus sin a plus 1 plus cos a plus sin a minus 1. Okay, so in the numerator 1 1 cancel, then we have 2 cos a plus cos a 2 cos a sin a plus sin a 2 sin a whole by, see this, cos a plus sin a cos a plus sin a. Okay, so let it be x. Okay, let it be x. It is in the form of x minus 1 into x plus 1, which is x square minus 1 square, means x square minus 1. So you can write it as, sorry, x square means cos a plus sin a whole square minus 1 square means 1. Okay, from the numerator 2 can be taken common, so remaining is cos a plus sin a by, let us expand this. Okay, cos square a plus sin square a plus 2 cos a sin a minus 1, this minus 1 minus 1. Okay, now what is cos square a plus sin square a? 1 1 minus 1 cancel. Okay, 2 whole cos a plus sin a whole by, this is 1 this is 1, 1 minus 1 cancel, I am not writing, by 2 cos a into sin a, 2 2 cancel. Okay, so let us divide part by part, means a plus b by x is equal to a by x plus b by x. Okay, we have already done such a means in such method in the previous part 1. So that is equal to cos a by cos a into sin a plus sin a by cos a into sin a, cos a by cos a into sin a by cos a into sin a. Okay, so cos a cancel, sin a cancel. What is 1 by sin a? Cosec a. Okay, what is 1 by cos a? Sec a, which is RHS. Hence proved. Okay, next example, we have m is equal to a sec a plus b 10 and n is equal to a 10a plus b sec a. Okay, and we are equal to prove that n square minus n square is equal to a square minus b square. We don't have value of a and b. Okay, but we have value of m and n. See, m is equal to this, n is equal to this. So let us start from LHS. Let us start from LHS. N square minus n square. So m square minus n square means a sec a plus b 10a whole square minus n square means 6 square a 10a plus b sec a whole square. Okay, we have to expand this. We don't have any other option. A plus b whole square. So a square sec square a plus b square 10 square a plus 2ab. So 2ab sec a into 10a minus this part is over. Okay, minus. Now we have to expand this. Be careful, minus n is there, so put bracket to avoid mistake. Okay, minus bracket again a plus b whole square. So a square 10 square a plus b square 6 square a plus 2ab sec a into 10. Okay, now let us open the bracket. This will be cancelled. Okay, so a square 6 square a plus b square 10 square a plus 2ab sec a into 10a minus a square 10 square a minus, all will become minus b square 6 square a minus 2ab sec a into 10. Okay, so 2ab sec a 10a minus 2ab sec a 10a cancel. Now let's try to group. Okay, see this one and this one. We can take common a square a square. So let us put them together. A square 6 square a minus a square 10 square. Okay, then see this one and this one. This square can be taken common, so let us put them together. B square 10 square a minus b square 6 square a. Okay, from these two we will take common. Now there are 4 terms, we will convert to 2 terms. So common is a square, remaining will be 6 square a minus 10 square a, which is 1. Okay, in the next step we will do 1 plus b square common. So b square whole into 10 square a minus 6 square. Okay, this is our target. So which is equal to, this is 1. Okay, a square into 1 now plus b square into 6 square a minus 10 square is 1. So what will be 10 square a minus 6 square a? Obviously minus 1. Okay, if a minus b is equal to 5, then b minus a will be minus 5. So this is minus 1. So a square minus b square, which is RHS. Hence proved. Okay. Let us move to next example. Next example. Sin a plus cos a is equal to m. Sin a plus cos a is equal to m, and sec a plus cosec a is equal to n. We have to prove that n whole into n square minus 1 is equal to 2n. Obviously, the LHS is more complicated, so let us start from LHS. So LHS is equal to n means this one, okay? Sec a plus cosec a. Many students forget to put bracket. Don't forget to put bracket, okay? It is very important. Whole into m square minus 1. M square means its square. Sin a plus cos a whole square minus 1. Okay? Brackets are very important. Okay? Next, let us not disturb this one. Let us do something with this. Sec a plus cosec a whole into, let us expand this. This is sin square a plus cos square a plus 2 sin a into cos a minus 1. Okay? This is 1. Sin square plus cos square is 1. 1 minus 1 cancel. Okay? In the next step we can cancel. Now already you have got sin a cos a. Okay? So let us simplify this. Means change them to more simplified form. Sin a cos a. So sec a is equal to 1 by cos a, and cosec a is equal to 1 by sin a. Okay? Whole into, these two are cancelled. 1 minus 1 cancelled. 2 sin a into cos a. We got 2. We need 2. Okay? Slowly we are getting. Okay? Now we don't have any other option. We have to open the bracket. We have to expand. Okay? So if you multiply this and this, 2 sin a cos a by cos a plus, then this into this, 2 sin a cos a by sin a. Okay? Cos a cancel, sin a cancel. So that is 2 sin a plus 2 cos a. Again 2 can be taken common. So 2 whole sin a plus cos a, which is equal to, what is sin a plus cos a? Sin a plus cos a is m, which is equal to RHS. Okay? Hence proved. Okay? Next example. Next example. Cos a by cos b is equal to m. Cos a by cos b is equal to m. Okay? Then cos a by sin b is equal to n. There are two angles, A and B, so be careful. Okay? One angle, then it is easier. we have to prove that n square plus n square whole into cos square b is equal to n square. Okay, this we have to prove. Okay, so let us start from LHS. It is more complicated, as you can see. LHS is equal to m square means its square, cos a by cos b whole square. So that is clearly cos square a by cos square b plus n square means cos a by sin b whole square. So that is clearly cos square a by sin square b. Bracket is there, whole into cos square. Our target is n square means cos a by sin b whole square. Okay, so what we can do, we can take LCM inside the bracket. Cos square b into sin square b LCM. This will be multiplied with this and this will be multiplied with this. So cos square a into sin square b plus cos square a into cos square b into this part is over, this part remaining is cos square b. Cos square b can be cancelled. Okay, then from these two terms in the numerator, from these two terms we can take common cos square. See, cos square a, cos square. So common is cos square a, remaining is sin square b plus cos square b whole by sin square b. This is 1. Sin square b plus cos square b is 1. So we got cos square a by sin square b. Okay, which can be written as cos a by sin b whole square. What is cos a by sin b? N. So we got n square, which is RHS. Hence proved. Okay, hence proved. The last example of this part. Okay, last example of this part, part 2. Let us take x cos a plus y sin a. X cos a plus y sin a is equal to m. And we have x sin a minus y cos a is equal to n. And we have to prove that x square plus y square is equal to m square plus n square. Okay, this we have to prove. X and y, no value is given, but m and values are there. See, m is equal to this, n is equal to this. So let's start from RHS. Sometimes you have to start from LHS, sometimes you have to start from RHS. LHS, sometimes RHS. So RHS is equal to, what is m square? It's square. X cos a plus y sin a whole square plus what is n square? It's square. X sin a minus y cos a whole square. Okay. We don't have any other option. We have to expand. Okay. We have to open the bracket. A plus b whole square, a minus b whole square. So this will become x square cos square a plus y square sin square a plus 2xy cos a sin or sin a cos a. Same thing. Sin a cos a. This part is over. Now let us move to this part. Plus, so you don't have any problem. If minus sign, then be careful. Put bracket to avoid mistake. Okay. A minus b whole square. So x square sin square a plus y square cos square a minus 2xy sin a into cos a. Okay. You can see 2xy sin a cos a minus 2xy sin a cos a cancel. Okay. These two terms, nothing is common, but see this and this. Okay. And this and this. X square cos square, x square sin square. X square can be taken common. Okay. So from this two I am taking common. X square common cos square a plus sin square a. Okay. Then from these two cross out. Okay. Y square can be taken common. So y square remaining is sin square a plus cos square a. Okay. This is 1. This is also 1. So remaining is x square plus y square, which is LHS. Hence proved. Okay. So this is the end of part 2. Thank you for watching.